Welcome all. Today we discussing the topic Newton's three laws of motion. Before getting into the topic, we have some interesting questions to answer. First, we know when we travel, seatbelt is compulsory. Why it is so? Second question, when playing cricket, fielder pull his hand downwards while catching. Why? Third question, when a shooter fired the gun, what makes him push backwards? All these questions' answers are connected with Newton's first, second, and third law of motion. English mathematician and great scientist Sir Isaac Newton further studied Galileo's ideas and presented three fundamental laws of motion. When an object at rest tends to stay at rest, an object in motion tends to keep moving. This property is known as inertia. And this is what exactly Newton's first law says. That is, his first law states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. And this first law of motion, also known as law of inertia. Here comes what we asked in introductory part, the importance of seatbelt. A vehicle travel in any direction or any speed, the traveler's body have a tendency to move in the same speed and same direction of the vehicle. So, because of this inertia, when suddenly brakes applies, the body tends to move forwards. If seatbelt is not applied, then it causes an injury. Now we can discuss with the second example. The traveling in a bus can be explained on the basis of law of inertia. When a passenger standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that start moving, whereas the upper part of the body continues to be rest because of the inertia of rest. Now we can discuss the second law of motion. The law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. From this law, we get how much force is applied. We know rate of change of momentum is directly proportional to change in momentum by time. For this, here we apply force instead of rate of change of momentum because these two are directly proportional. So we have F proportional to m into v minus u by t. Change proportionality sign by multiplying with a constant k, and the change in velocity with time is acceleration. Hence the equation becomes F is equal to ma. Now we can analyze the second question in the introductory part. Here from the mathematical equation of second law, one thing is clear that the force is directly proportional to mass and acceleration, but inversely proportional to time. Inversely proportional means when one quantity increases, the other quantity will decrease. A cricketer moves his hands backward because by doing this, he increases the time due to which the rate of change of momentum decreases. That means that the ball comes to rest gently and does not hurt the fielder. But if does not move his hand backward, then the ball would come to rest in fraction of second with a high rate of change of momentum. The ball will exert a lot of force on the hand of the fielder, which will hurt him. And next, we have the third law of motion. Law states that when one object exerts a force on another object, the second object instantaneously exerts force back on the first. Here, these two forces are known as action force and reaction force, respectively. Here in these examples, the air rushes down is the action and the balloons goes up is the reaction. Overall, the third law of motion states that To every action, there will be an equal and opposite reaction. Here, one thing is clear that action and reaction are equal in magnitude but opposite in direction. So the net force is always zero. And now we can analyze the third question in the introductory part. He would have a gun at the time of firing in television. But how does the third law act on it? When a bullet is fired from a gun, the gun exerts a force on the bullet in the forward direction. This is the action force. At the same time, the bullet exerts an equal force on the gun in the backward direction. This is the reaction force. Does the gun recoil? That is, the gun moves only a little distance backward. What is the reason behind this? This is because of the greater mass of the gun. A quick summary. Can you recall the Newton's first law, second law, and third law of motion? First law of motion. An object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. Second law states that rate of change of momentum of a body is proportional to the applied unbalanced force in the direction of force. Then Newton's third law states that for every action there is an equal and opposite reaction. So I hope you understand well, so I ask some questions. State third law of motion. So we already know the third law states that every action there is an equal and opposite reaction. Second question. Which law gives the equation F is equal to ma? Yes, the second laws of motion give the equation F is equal to ma. So I will give you an extended activity. Find out more examples of three laws of motion. Thank you for watching.